Hello, this video will be covering a section of the Prelude Autograding questions documentation, and more specifically, this video will cover the Autograding with GPIO Registers section of the documentation. So that would be pages 14 through 20. So in this video, we are going to continue talking about autograding, different types of questions, and more specifically, this video is going to cover how to autograde questions where you are randomizing GPIO registers, since it's a little more difficult to kind of hard code the correct answer for the GPIO port register bit configuration, and you also can't really run tests like you would for C programming questions. And so for this question in particular, it's having the student it's having the student write a function that initializes the UART, and part of initializing the UART is having to configure GPIO port registers to set up different functionalities, like having to enable alternate functions, set parochial functionalities, and then like setting pin directions in analog or digital modes. And the way we went about autograding this question is, after we've done our randomization and we figured out, okay, what GPIO port registers are we going to use that, associate with the randomized UART module picked, we then use this file here, this GPIO.py file, which allows us to use methods to actually come up with the correct GPIO port configuration, or the correct mask that's going to be used then for autograding and checking the student's answer for this question. So for this file here, the student, or to use this file, you need to import the GPIO device class into your into the server.py file where you're actually going to be doing the autograding. And within this class, for the constructor, it's going to initialize all of the different GPIO port registers, which it calls this function here the GPIO port reg function. And when you call that, and then initializes the different GPIO port registers and just declares them to be 0. And then in this GPIO device class, you then have a couple functions here. Two functions actually deal with the GPIO port clock and actually setting the bit configuration of these clock registers. So for the first function here, if you give it the port ID parameter, which is just the value of the GPIO, the different GPIO ports. So for instance, A is going to be port ID 0, B is going to be port ID 1, and so on and so forth. And then the value is, this isn't really something you need to worry about, but because it's usually just going to be 1. But then it's the value that you'd like to set the bit to be. And so here, if you give it a port ID of A, then this function is then going to figure out, okay, what does the clock register, what is its final bit configuration state need to be in order for the GPIO port A register to be enabled. And so that's essentially what this function is doing too, just without declaring the which port to enable. And then you have two getter functions here, which then so once you actually call these set functions, right, and they update the GPIO clock variable with the correct value that or with the correct value that you wanted based off the parameters here, and then these getter functions actually then return that that GPIO clock register with the values that you wanted, and then you can utilize this class here, the GPIO port reg class, which is initialized within this class here, within this class's constructor, and it is using kind of the same setter and getter functions um, for figuring out how you want to. So, like for the digital enable register here, based on the pins that you want to enable. Um, so, like for this function here, based on the pin ID, such as enabling pin 0 or bit 0, or I guess pin 0, pin 1, pin 2, pin 3, it'll take care of that for you, applying the bit mask as necessary to get you that final value, and then you have a getter function to then return the value of that updated register state. And same thing for the DIR register and the data register and so on and so forth. So this function is mainly here to calculate the register values and then allowing you to extract those values to the server.py file and be able to set the correct answer variables. Um, and so looking at how to actually use this GPIO file, you first need to import that file into your server.py file. So from GPIO, which is from GPIO.py, you want to import the GPIO device class, and then you want to run the constructor of that class, which is then going to run the constructor, or it's going to initialize, it's going to run class GPIO port reg, and it's going to run its constructor to initialize all of the different GPIO port registers, and essentially kind of get all of the variables ready to be modified. And then to actually use the different setter and getter functions. So starting off, if the first GPIO register that's going to need to be modified within this problem is the kind of clock register, where you need to enable the clock for the GPIO port C, or for GPIO port C. And so to figure out what the mask needs to be, or what the final value of the GPIO clock register needs to be, what you're going to do is, first you got to figure out what the port ID is going to be for the argument for the setter function, which is pretty simple, where all you need to do is just find the index for the port name. So in this case, right, we're working with port C. So we'll just find the index of port C within this array here, and so that'll be 2. So port ID for C will be 2 here. And then we'll give that as a parameter for the set port clock enable function, where once again, that'll be this function here, where the port ID is for C, and then the value for that port will be 1, so enabling it. So enabling the port C clock, and then it's going to update the GPIO clock register to enable the clock for port C, and then to actually get that value from that register variable, we'll then call this getter function here, where you don't necessarily need this argument, but it's just going to return the current value of the clock register, and then we can capture that into this variable here. And then since, or to make sure that the value then is updated or is formatted correctly based off what the students are going to be writing, we'll then make sure to convert that that value into an 8-bit binary string, and then set that to the GPIO, or the RCG C GPIO mask correct answers variable, which will then be used in the question.html file. And then looking kind of at another example of using the GPIO.py file is when we want to figure out the correct bit mask for the PCTL register. So to do that, we'll be calling the set port pin PCTL function, where for that function, if I scroll over to that, that's also going to be taking the pin ID. So, if you're going to be messing with pin 0, pin 1, pin 2, or pin 3, and so on and so forth, and then what that value of that pin needs to be. So going back here, so if the UART is in receive only mode, then we will, so I guess this for loop above figures out what the pin ID is going to be, and then also determining what the value is going to be. And so we just give those two arguments to this function here, and then it's going to update its PCTL port register variable with the correct value for updating that pin with the value that you gave it. And then if it's receiving transmit, it's going to kind of do the same thing. And then if it's transmit, it's going to do the same thing, just updating that PCTL register with the correct bit configuration depending on the communication mode. And then you can call the getter function, which will be get port PCTL to then get that final PCTL port bit configuration, so that you can then capture it into a variable, make sure to convert it into an 8-digit hexadecimal value, and set that as another correct answer. That will then be used to check the student's code and be part of the auto-grading process. And then if you were kind of doing something different, so for this question, right, students are kind of filling in these text boxes here for setting the correct bit masking for these GPIO port registers. But if you have a question here where you're randomizing what GPIO ports are being used, and you're having to write C programming, or you're C programming or writing a C programming function here, then you might want to instead use this CPRE288 GPIO.cpp file, which is essentially the same thing as this file, which has setter and getter functions for all the different GPIO port registers, except for this is just in a C++ format. And then you'll put this into, or you'll import this and use this into the file that's actually setting up all the testing and doing stuff like that. That's just mainly doing the testing. And then in the test.py file, you'll just need to make sure that when you're compiling the the student's code, and then for this question, it also has a separate file where it's generating the correct solution. So you need to make sure to compile that too. But then every time you're also, or when you're compiling both these files, you're also adding in the CPRE288 GPIO.cpp file, so that it can be used within these two files to call those getter and setter functions to calculate or generate the correct value for each GPIO port and clock register.